This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we make lightning protection easy. If your wind turbines are due for maintenance or repairs, install our Strike Tape Retrofit LPS upgrade at the same time. A Strike Tape installation is the quick, easy solution that provides a dramatic, long-lasting boost to the factory lightning protection system. Forward-thinking wind site owners install Strike Tape today to increase uptime tomorrow. Learn more in the show notes of today's podcast. Welcome back. I'm Dan Blewett.
I'm Alan Hall.
And I'm Rosemary Barnes.
And this is the UPTIME podcast, bringing you the latest in wind energy tech, news, and policy. All right, welcome back to the UPTIME Wind Energy Podcast. I'm your co-host, Dan Blewett. On today's show, we've got an exciting episode. First, we're going to chat through a couple different environmental issues. Missouri's been having some issues with bats. Ameren, which is one of the big electrical utilities out in the Midwest, has had to shut down some turbines due to bats, so we'll talk about some of the issues there. We're also going to chat a little bit about pile driving noise as it relates to offshore wind construction, which is a big issue with our friendly undersea mammals, because obviously sound travels very fast underwater and pile driving is very, very loud. We'll also chat a little bit about an interesting case in Australia where a man living in a remote off-the-grid cabin is suing one of the wind farms out there for just essentially the whooshing noise that comes from these blades tearing through the atmosphere. So we'll talk a little bit about that and what might come of it. And then we have a great friend of the UPTIME podcast today. Michel Holm from Cotes is joining us to talk about humidity issues in wind turbines. So look for that in about 15 minutes. Great conversation with him on all the ins and outs of humidity and what damage it can do to wind turbines onshore and offshore and some of their technology behind it. And then lastly, we'll talk a little bit about the GE Siemens Gamesa patent lawsuit, which has just gotten a new ruling. And of course, Siemens Gamesa is going to appeal that ruling. We'll talk through some of the implications there at the end, but a very full show today. And our first friend of UPTIME. So we're excited to talk to humidity expert Michel Holm in a little bit. But before we get going, let me remind you one last time, sign up for UPTIME Tech News, which you'll find in the show notes or description of this podcast. And again, that's our weekly update newsletter where you'll just get, hey, here's the new podcast. Here's some great insider news around the wind industry and renewable energy industry. And you can sign up for that in the show notes of this podcast. A great way to stay connected if you enjoy the show and want to stay up to date on everything wind energy, renewable energy, and tech. No Rosemary Barnes today. She's out of the office, but we'll look for her next week. And of course, be sure to sign up for her YouTube channel, subscribe in the show notes as well. So Alan, let's start with Missouri. So one of their largest wind farms is not running at night because they've had issues with bats and they don't want to kill. There's an endangered species out there that they don't want to kill. So kudos to Ameren for making the decision to shut these off. They've honestly, it seems like they've taken the high road and said, yeah, we're gonna err on the side of caution and with this species, but people are not happy that because they're not running 24/7, they're losing a significant amount of capacity that it sounds like Ameren wants to pass on to ratepayers. So, Alan, this seems like it's a pretty big issue.
Yeah, this is going to grow in terms of an issue, particularly in the United States, because there's such a wide variety of wildlife, birds, bats that are around wind turbines quite a good bit. And as the number of wind turbines increases and the density of them increases, you're going to find places as birds and bats are sort of migratory creatures. When you initially sited the wind turbine location, you had done a survey. You do surveys of bats and birds in the area. And things change over time. So now Ameren is forced to shut down the wind turbines from essentially dusk until dawn, which is then, they are losing a big revenue source from that because they're not creating power and selling power. And yet they have this capital expense of all these wind turbines. So now Ameren is going back to the ratepayers and saying, we need more money to cover our costs because we can't generate as much electricity. It's sort of a circular fight that's going to develop here, you have to wonder if something in this equation is missing right now. What's the dog that's not barking in this little bit of a fight? Which is, there are means to mitigate bats and birds around wind turbines. We've talked about them on the podcast a couple of different times, and you wonder, have they implemented some of those changes? I know there's been some researchers down at Texas State University, I believe that's where they are, that have done a number of studies of how to repel bats away from wind turbines and to mitigate some of the losses there. But none of the articles we've seen talk about that, which is a little strange, because maybe Ameren is playing the longer game here and is going to want to implement something like that, but they're going to obviously have to seek regulatory approval before they go ahead and install bat repellent or bird repellent systems in Missouri, right? So Dan, do you see how this gets like super complicated really fast, and then eventually it all seems to revolve around the money?
Yeah, I mean, because if Ameren said, hey, this was going to be the rate based on 24 hours of production per day, and now it's at 16, that's a big rate increase for them to make things add up. And of course, the pushback is that, hey, you guys knew where you were building this wind farm, and you knew what potential environmental risks there were when you got this permit. And they did get, they got a permit from the U.S. Fish and Wildlife Services to operate in a way that was going to be eco-friendly. But they still, they knew the risk. So it's like, why should we pay for your mistake if you didn't, figure this out ahead of time? Or why didn't you just put this somewhere else? There's other land. Like Missouri has quite a bit of flat land, as you know, growing up in Wichita, and I lived in Illinois for many years. That's not to say it's not owned by someone, obviously, but there's a lot of places you could potentially put a wind farm. But they settled on this one, and it's not working out that well. So why should the ratepayers fix and pay for their mistake? That's the big question. All right, so moving on, in a similar vein, just a different sort of scenario is we've got to figure out a way to mitigate sound when doing these offshore wind installations. And, marine animals are having a tough time coping with some of these human stressors. So there's a lot of technology out there that needs to be improved, needs to be developed to attenuate some of this noise. Because, I mean, Alan, have you heard pile driving? Is there any major construction around you? There's some here in DC that I've walked by. I actually walked by a new building where they were driving piles. And of course, it's they have an explosive shot that drives the pile driver. So every, hundreds of times a day as they're starting the foundations of these buildings, you hear this little mini explosion, sounds like a very loud gunshot, followed by this piston, colliding at high speed with this steel beam, right? It's incredibly loud. You don't want to even be a couple blocks from it. So you can imagine some of these whales, animals that have incredible, they navigate the world through sonar, right? This has got to be incredibly disruptive to them, if not just downright harmful. So some of these systems where they're encasing the piles, almost give it a sort of a barrier. So they're driving the pile inside it, and they've got this sort of this tube around it to help attenuate some of it. They're trying gravity-based foundations. There's a lot of efforts to to reduce this, but pile driving is over 200 decibels, which is, again, crazy loud. I mean, how much do you feel like we can actually do this, though? I mean, driving piles into the earth, no matter whether it's subsea or not or otherwise, is it takes a lot of energy to do that.
It does, and that's why it's so noisy, right? Is that you're trying to drive an object in the ground, and the ground doesn't want it in there, so you just have to overcome it with force, and that force creates obviously a lot of noise. And the difficulty onshore in suburban environments and big cities is it does create so much noise that they actually limit the times in which those things can operate, right? So they don't operate them at 10 o'clock at night, for example. So humans do not like the noise, and obviously wildlife and creatures in the sea are not going to like it either. I think this is one of those pieces of technology we don't think about very much, right? That the wind turbine industry in general is looking out for the wildlife and the environment in which they're operating in. So they're trying to develop different pieces of engineering to dampen the noise as they put these pilings into the ocean. And it makes me wonder, with this advent of and the proximity of floating wind, that because this noise of driving the pilings and doing all this work can be rather difficult, does it make sense to move to something like a floating wind platform where you don't have to drive pilings in like that, just because, one, is probably cheaper to do in terms of this, you're not driving pilings, but secondarily, the environmental aspects may overcome the sort of the technical aspects, where you're going to have rules at some point that are going to limit how much noise you can make when driving a piling into the ocean floor. That will happen in the United States, I guarantee it. And don't you think it's going to happen in Europe if it hasn't happened already?
Yeah, probably. And of course, it sounds like these gravity-based foundations are like the way to go, because you're essentially just sinking a gigantic concrete block that's going to sit on the top of the seabed. And if it's big and heavy enough, that should do fine, right? I actually heard a fun fact about our Capitol, that on top of the Washington, D.C. Capitol building, there's a statue. I can't remember the figure who's up there. I think it's like a Lady Liberty kind of thing. Don't quote me on it, but apparently it's so heavy that it's not actually anchored. It's like solid cast iron, that it's so heavy that it didn't need to be anchored. So it's just like, wow, many tons. Don't matter how hard the wind blows, it ain't moving, right? So kind of the same thing. And obviously, if you're just sinking stuff, but one of the challenges that those gigantic gravity-based like blocks essentially would need to be manufactured locally. But again, 3D printing, like that could be, and making these things at the port is going to make a lot more sense. So as we continue to push towards like the local materials, local workers, 3D printing, where you can just make some of these things a lot easier without having to build a gigantic concrete plant, then hopefully that will probably win out. Because you just think about, you make a bridge, you're going to drive pilings for a while, but then you're going to stop. If you're installing 100 turbines offshore, for example, which would be a really big farm in one location. Yeah, of course there could be thousands in the grand scheme of things, but in one location you're driving pilings for years on an end, maybe, right? Like just continuing to drive pilings. And if there's whales and all these bigger creatures in that area, not that the smaller creatures don't matter, because they do, but you could just see like there could be tons of whales turning up dead on a beach, because this relentless pounding over many months and years could just ruin them, and it'd be really sad. So hopefully, they can figure this out, because of course with the aircraft industry, they're constantly trying to reduce some of that noise, and there's huge environmental studies. If you want to put another runway into an airport, if you want to increase capacity at an airport, I had a friend who did these environmental studies, and they had to figure out how much noise, if we want to add a runway or we want to increase how many planes can land here each day, what's that going to do to the noise, to the surrounding communities and the wildlife? It's a really complex problem. So moving on here, this is an interesting trial over in Australia. There's a Victorian wind farm that's been a nuisance to some neighbors. Now, one of these neighbors bought a property in 2008 with the knowledge that a wind farm would be built there. So the farm was approved in 2004, construction started in 2011, and again, this man bought the property in 2008. And of course, it started operating in 2015. And now he says he can't sleep, often has to sleep in his car, kind of drive far away to kind of get away from him. And it's just, this is kind of like the human equivalent of the pile driving, right? A whale might not be able to get away from this. That's like their native area. So, what do you read this article? What do you think about this situation? Obviously, it's difficult. This man was living off the grid in a cabin he built, really kind of out in the wilderness. How can a person coexist with a wind farm like this? And is it kind of a he said, she said thing?
It is. It's very similar, I think, to people who buy a house near an airport and then complain about the air traffic over top of the house. It's there, and there's going to be airplanes flying over it, but you still decided to buy the home knowing that, and then you want to complain all the time and close down the airport, which has happened multiple times in the United States where they have closed airports or limited airports. California comes to mind, where they've limited airport access to certain times of day because the neighbors are complaining. Okay. And wind turbines are going to go through that same sort of evolution. Now, they haven't had a universal edict like airplanes have. Like airplanes manufactured in any part of the world have noise requirements. Like as part of getting certified to be an operational aircraft, you have to meet certain noise requirements. Wind turbines haven't done that yet, but we're rapidly getting on that pathway. And if we're going down that pathway, that means we need to develop quieter blade systems, right? Because I think this kind of problem that's highlighted in Australia is repeated all over the United States right now. You see all kinds of complaints about noise, flicker, and those need to work themselves out, right? But I think as the industry, the wind turbine industry evolves, there's going to be certain things that we do to make the blades quieter, very similar to what we do on sort of jet engines. I know that the technologies are different and the environment's different, and how they operate's different, right? But we have made a lot of progress in terms of the way the aerodynamics on a wind turbine blade even work. We're using supercomputers to design them now, which we didn't used to do. So, they're getting better. The question is, are you going to end up in court all the time for these noise issues? And I, feel sorry for this guy in Australia. What are you going to do? Right? I guess you're going to have to just move yourself away from the situation, which is not ideal.
Yeah, it's hard to know because one person's experience, like no one's privy to the way he internalizes it. Whether it's as loud as he says it is, like that they're roaring. No, I mean, no one can say. So really, at that point, it's just like, well, should you have built your house here? Knowing that this wind farm was approved and this could be a potential thing, which it turned out to be. So yeah, it's complicated. But again, you don't know. Everyone could internalize it different. I mean, I had a similar problem. I had an apartment where a nightclub moved underneath it. I had to move 2 months later. It was incredibly loud. I think most people would have had the same issues that I had, but not everyone. Some people can sleep through a freight train rolling down the street. And so it's hard to know. Okay, because again, we don't know what the whales underneath the sea, how they feel about pile driving. We don't exactly know this man's experience. So there's definitely some give and take there. So we're going to transition now to our conversation with Michel Holm from Cotes. He is the Chief Commercial Officer for Cotes. And of course, if you don't know much about Cotes, they do commercial dehumidification, dry air systems for lots of different industries, one of which is wind. So they've got some really interesting tech. And of course, with offshore being such a big deal and such a boom in offshore development now, and with such a harsh environment offshore, this is going to become more and more of a significant conversation with insurance underwriters between the manufacturers and operators, just to make sure these machines can operate not just for the first couple years without problem, but long into the future. And one thing to note, we've had a lot of guests on the show, and Al and I are wearing our collars here, but Michel Holm's a fun guy and was rocking his AC/DC t-shirt for the interview because he's more than just a suit. He knows his stuff, but he wanted to rock his AC/DC. So we appreciate that about him. So without further ado, we're going to kick to our conversation with friend of Uptime, Michel Holm from Cotes. All right, so we're here with Michel Holm from Cotes. Let's talk a little bit about humidity. We've chatted getting ready for this episode about it being a bit of a hidden devil. One of those things that kind of gets tossed aside, not as much considered in some of the planning and some of the construction. And one of those things like, why do we need that? But obviously not everything can be coated inside of a wind turbine, right? Whether you're in the nacelle or the tower. Not everything can be galvanized. Like not everything can be, weatherproof from humidity, which is, as a gas is just going to reach and out and touch pretty much any surface within these. So what do people need to know about the components that are maybe at the highest risk from, some sustained humidity within a wind turbine?
Yeah, but first of all, let me say, maybe you're also good to go in the first couple of years because you won't see any problems. So you won't see any humidity-related issues before, 4 or 5 years down the road, typically after warranty runs out on your turbines. But after that, then you'll see, the long-term effects. And that, electrical systems are the items or the components that you of course have to be most critical about, because, water and electronics don't mix very well. But then it also goes into, it could be on some of the mechanical stuff, because then you'll start to see corrosion. And also from a health and safety point of view, you'll see mold growth.
So this is something that people definitely need to plan for the future. Like you said, they're not going to see any issues in the first couple of years. But what are some, besides corrosion? I mean, arc flashes, is that something that people could potentially worry about? In terms of arc flashes, of course, if you have a lot of humidity, you can see these kind of things happening. And we have seen, transformers or converter modules basically blowing up due to high humidity. And that's just when it starts to condense, or is it the humidity itself? That is, of course, you have high humidity levels. And then, of course, then you will see when you then start powering up that turbine or that component, then the power will simply just jump, and do a shortcut, because, water leads electricity. Simple as that. Alan, you're an electrical engineer. I mean, is this something that's been plaguing a lot of industries? Is this new to wind turbines? I mean, you've been obviously dedicated a lot of your career to lightning protection, but how much of the environment do people need to worry about with any heavy machinery? In any large piece of machinery, water and condensation are a huge problem. I know we talk a lot about aircraft on our other podcasts, but aircraft accumulate water in buckets, gallons on a flight from condensation, and it's a tremendous problem there. On wind turbines, it's the same sort of issue, but it's slightly different in the sense that a lot of wind turbines are located near the water or in the water. And there's so much electrical equipment, particularly expensive electrical equipment in a wind turbine today. Condensation and water accumulation combined with dirt and salt leads to electrical problems throughout the turbine. So it's not a matter of if, it's a matter of when these problems are going to occur. So keeping the humidity controlled inside of the wind turbine is really critical for that long service life. And so, Michael, I mean, a lot of services are coded, right? I mean, are there any services within a turbine, whether it's a tower or then a cell, that aren't coded, that are maybe getting touched by humidity and then seeing that corrosion later on? I mean, why couldn't they just coat everything? Yeah, they could, but then there's also a cost perspective into this. And, in the lack of, knowing better, people have just, doing, C5 or C4 or even, C5 offshore on the internals of a turbine, because they didn't know any better. And that's just driving up cost unnecessary. So if you can control the environment, you can go for a lower corrosion class, or you can go for lower IP classes on your electrical components. But then people have just tried to, to protect themselves in the best possible way that they knew how to solve it. Can you speak a little more about that? So I'm not that familiar with the different classes of coatings and corrosion protection. So what you said, a lot of people just try to combat this from a coating standpoint and just throw the thickest, most protective coating on. Is that right? And whereas exactly, they could probably go a little cheaper and make it easier on themselves just by dehumidifying. Exactly. So we see this, in other industries where, on the inside of bridges or the big constructions, they don't even paint, they just keep it dry, because that will save them tons of paint. So it will lighten the weight of the structure, but also in terms of O&M and maintenance. And also just imagine that, you have a service technician crawling up the inside of the turbine, he chips the paint, then you need to send out a new guy to repair this damage. And so it's just layer after layer after layer. But I've been into the wind industry for 13 years or so. And, I think it's sometimes, some kind of involvement that, at that point when you start doing this, you had other bigger issues or battles to fight. And now this comes up. Yeah, so it's one of those things that's kind of insidious, where you don't think much about it, and then 5 years later, you're like, man, we've got a lot of issues. And 15 years ago or 20 years ago, a turbine was built like, John Deere tractor, old school kind of thing. It was heavy duty metal and not so much electronic components, and that has now changed. Mm-hmm. But you still live with old designs. Yeah. So the more mechanical systems probably were much more resilient to humidity and some of these other environmental conditions. Yeah, that makes sense. So okay. So what does an operator do if they don't have a dehumidifier installed? Have there been sort of like folk solutions? Like, do they turn up the heaters? Or do they ventilate? What do they do if they Or what are some of the things that people do that maybe work or maybe don't work, or they maybe just sort of trying, hoping to get some sort of result from it?
Exactly what you're saying. Folklore solutions like getting external heat to try to blow up the tower to dry it out, or big fans or ventilators. In some parts, they also some also install small what is called heating elements inside the electrical cabinets, to heat it up and make the water evaporate. The downside to that is, of course, you stress the electronic components because you start heating them up. You can, in fact, retrofit a turbine with a dehumidifier. It's not a big deal.
Gotcha. So those, I mean, are people starting to get away from those solutions? I mean, is that going to make, it sounds like that would exacerbate the problem, because I don't know, Alan, is the cocktail what? Humidity plus salt plus heat? That's probably like the worst cocktail. Am I right?
Being cool tends to be the worst because it condensates, and then you have these conductive paths created by the salt and the water. But Michael's right. The heater implementation, which I've seen on electrical cabinets, has its own problems, and it really decreases the lifetime of the electronic components. Transistor type equipment doesn't like to be hot, and so the more it's hot, the shorter its lifespan will be. So it's going in the wrong direction. It's fixing one problem, but it's creating probably a more expensive problem secondarily, which is not the right way to go. You need to remove the water from the air. That's what you need to do. Okay,
so when, if you're an operator and you get your turbines from GE or Sislone or Siemens Gamesa or whoever, Vestas, is it highly site specific, or is there like a suggested, keep your turbine either this well coated or at this humidity level and don't exceed it, or how does that dialogue go about the difference in installing a turbine in one site versus another, and then like maintaining the right humidity level where everything is going to go according to plan over the lifetime of that turbine?
So it's site specific. So the OEM will then suggest, for this site you need a C5 or C4 corrosion class, and I think that's I think they agree all on the local weather conditions. They look up into some weather data and say this is a C5 environment or whatever. So, but on the other hand, we actually see now some developers and operators now start setting demands and humidity or climate criteria to the turbine. To the OEMs. So say, okay, you have to control the humidity on the inside during transport, construction, and operation of the turbine. So we don't accept, anything above 60% relative humidity because then, we are afraid that this will harm, our product. So, and then from an owner point of view, it's like, I don't care how you solve it, Mr. OEM, you just need to solve it.
Whether that's coatings or humidifier or dehumidifier
exactly.
Or whatever.
Yes.
Yeah.
Yeah.
Gotcha. I mean, that makes sense because as a manufacturer, you don't want to have all these warranty claims that you're like, hey, if you'd taken better care of this wouldn't be an issue. Like you wouldn't have fried electronics if there wasn't all this condensation inside the turbine.
Exactly. And also on the side here, you have the insurance companies. They'll say, we will not insure, or also the banks, we will not finance this project unless this turbine has a certain a specific corrosion class or any kind of protection into it, also simple as that.
Okay, so let's talk a little bit about the onshore versus offshore. Obviously, offshore installations, they're much more aware of the harsh environment. What are some of the pieces that are especially at risk in an offshore installation? It's
more or less the same. It's just on a bigger scale. It's more remote. It's less accessible. You could be 50 miles out offshore, and you can only go to this site, 2 or 3 times a year. So if you have failure, you don't want to go out, now and then and stop the turbine. It's too expensive. So you say the stakes are simply just higher, but the same thing can fail.
But would there be more protection? Like, the foundations, like transition pieces, the substations. It's got to be everything, right?
Yeah. So of course, on the externals, everything is C5 or C6 corrosion, offshore corrosion class. It's like in the oil and gas industry. And on the inside, they will also try to protect as much. We work with some of the OEMs and say, with a dehumidifier, we can then go for a C3 or C2 corrosion class because there's a huge cost out opportunities in lowering your corrosion class on the internal side. So if you have a function, climate protection system inside your turbine, you could go down to a low corrosion class, and that's backed by industry standards here.
And then onshore, obviously the environment's going to be very different, but also still highly variable. Whereas there might be even a little more consistency in the fact that the environment's always harsh out at sea, right? But if you have a turbine in somewhere really north, humidity might be much less of a problem. I mean, what differences do you see in different parts of the world as far as onshore and what they have to do to protect from this?
Yeah, I think we see different symptoms, but I'll say more or less all over the world, onshore turbines also have a humidity climate challenge and an issue. You could find turbines in California or in the Gobi Desert that they're in a very nice and dry environment. They don't need it. But if you go to the Mexican Gulf, to Texas, or to inland climate, hot days, cold nights, you will see condensation building up as the temperature rises throughout the day. Yeah, you go to here in Denmark, and you have lots of rain, more than 100 days a year. You also have high humidity issues. So yeah, going to the Philippines or in Vietnam, I've seen onshore turbines being put up on a rice field. It's semi-offshore, right? So it's everywhere. And actually on the onshore side, and I could be a little bit off here, but they'll say you actually have offshore climate as much as 15 to 20 miles inland because of all the salt and the wind coming in from the sea.
I want to discuss the internal factors like mold. And mold is a big growing problem in industry because now we realize the health consequences of workers around mold and bumping into mold that they didn't expect was there and causing breathing problems and actually long-term health consequences from some of the particular kinds of molds like black mold. And are we seeing more of the industry drive to make sure that the air inside of a turbine doesn't have mold, that they're actually not just worried about the turbine itself, but worried about the people who are going to be working inside that environment? And has that changed? Has that sort of regulation and thought process changed recently?
Yeah, I think so. I think, for a long time, larger corporations or operators, they have a zero tolerance when it comes to mold. And then it's just a matter of, detecting it, how big should this black spot be before we see an issue. Some are super concerned about this. Others say, let's wait until someone complains. But all in all, it's not acceptable.
Yeah, and just dehumidifying that can really control the amount of mold that would even occur. So once it starts, it seems like it's very difficult to get rid of. In fact, if you have a mold problem inside of a wind turbine, you have to call a special company to come in to remove it. It gets very expensive very quickly, and it would seem like the cost trade-off of having someone come in constantly remove mold versus have a dehumidifying system doesn't even make sense, right? The dehumidifier is such a lower expense lifetime versus the constant risk, right?
Exactly. Of course, once you have mold there, a dehumidifier cannot remove it. So you need someone who can clean it up, and then you can install a dehumidifier to prevent it from coming again. And there's also another thing. It's like, we don't like water inside the turbine. So why do you go there and start rinsing it off, with a power cleaner? It makes no sense to me.
Yeah, those all seem like pretty terrible tasks to go power wash with some disinfectant all the internal surfaces looking for mold. That sounds awful.
Yeah, and just imagine if you also have to go out and do this offshore. Like, the costs are incremental in this. It's unbelievable.
Yeah,
Michael, the technology that you have is really interesting because one of the things I would worry about having a dehumidification system in a wind turbine, particularly offshore, is how reliable is it? Can it stay out there for years at a time and not need servicing? And just looking at your technology, you have a very maybe simplistic from the outside. I'm sure it's complicated on the inside. Technology. Would you like to explain how that technology works and how that system works generally?
Yeah. So we do what is referred to as an absorption dehumidifier. So there's different ways of you can dry out stuff. You probably know the dry bags from Home Depot. They have some kind of silica gel in them. The downside with these is like once they're full, and then they actually work as a sponge, and you need to go out and replace them. Then you have something what is referred to as a condensation dehumidifier that has a cooling surface. So you need to cool the air in order to get the water out. When you go below around 15, 20 degrees Celsius, it becomes very energy inefficient to cool the air to get the water out. And then we have this absorption technology that has been around for 70 years. So we take the silica gel and put it into a big rotor that only rotates like 7 or 9 RPM a minute. And then we pull the humid air through that. And then the silica gel will absorb all the water in the air, and then we distribute the dry air into the turbine or to a structure. And as this, big rotor slowly rotates, it passes by a heat exchanger or heat module, that more than say evaporates or burns off the water that we have just absorbed, and then send that hot and humid air outside the structure. And this can go on and on. We have some of our machines been running like 60 or 70 thousand operational hours, and then you need just to go out once in a year and replace a filter. So that's within the service manual. And if you're offshore, there's not a lot of dust in the air. Then you can look at the filter and maybe just put it back, but then otherwise you replace it. Occasionally there might be a drive belt or fan or something that that tears out after 40 or 50,000 hours. Then you can replace that. So in short, these machines needs inspection once in a year.
And so doing the math here in my head, running 24/7 for a year is about what, 7,500 hours or so. So you're talking.
Yeah, but not these machines. Yeah, exactly. But these machines don't necessarily always run 24/7. So either they come with a hygrostat, and then you can say if humidity reaches a certain limit, then the machine runs for a few hours, stops again until the humidity drops,
Gotcha.
And then of course builds it up again. So it can maybe run 3 or 4 hours within 24 hours, something like that.
Okay, so you're saying with a 70,000 year life, that's maybe 15 years?
Yeah, you could do that.
Depending on how often
exactly.
they're doing it? Wow.
Yes,
Okay.
or if you want to run it 24/7, we have a technology where we create, actually a patent technology where we create an overpressure inside the turbine. So we actually say then we pull a little bit of air out from the outside, dry that, and then send that in and that into the turbine. So with that overpressure, more or less, we seal off the entire turbine, and all the dry air will travel up through the tower, and then sneak out around the yaw or whatever. But instead of having other say polluted air coming in, that has to run 24/7. But we sell that to different OEMs, and with a service manual, they'll have to go out once every year and maybe every 5 years replace some of the main components, and then it should be fine for 25 years.
Wow. And so talk a little more about the overpressure. I mean, what's the main advantage of that? Just sort of like pushing the elements out. Is that a simplistic way of viewing it?
Yeah, because if you don't have this overpressure, for an onshore turbine, for instance, then you need also for an offshore turbine, then in order to distribute the air properly, you actually need to have 100 meters of ducting all the way up, and then have the dry air more or less drizzling down through the structure. If you have the overpressure, the dry air will climb up itself. So you don't need to install all of this, extra pipes. And then so you have that sealing. And for offshore, when we do this, we can also 100% efficiently desalt the air. Because if you just put a a filter to get the salt out, that will not work. And in best case, that manual filter will clog. And then you have a problem later on. When we do the overpressure and pulling the air out from the outside, we semi-dry the air, so to speak, and then the salt in the air changes form and crystallizes. When we dry it, I think it's below 55%, and then we can more or less pull the salt crystals out in a tray, and then we can send salt-free air into the offshore turbine.
And so the dry air climbs to the top naturally just because it's less dense than the humid air. Is that right?
No, it's just because you have the overpressure. Then it will climb up.
So the salt system doesn't have a filter on it as much as it just the particulates actually fall out of the air, so you don't clog anything. Is that the design of the system?
Yeah.
Huh, that's
wow,
clever.
That's really clever. Yeah. Yeah, I mean, these systems sound so remarkable, and I think one of the questions that I've heard from people I've talked to in the wind turbine industry is, well, how big is the system? Is it some massive piece of equipment, or what relative size? Say I have like a 1-2 megawatt kind of wind turbine. What size is the system, and where is it installed inside the turbine?
So, depending on what you want to protect, so everything goes to this kind of box, it's maybe like a moving box, cardboard kind of thing size, and up to American sized refrigerator, double door. That's the sizes of the units we do for the wind industry. We also do for other industries, and then we're up to 40 feet container sizes. If you want to dry, that's typically, for instance, for pharmaceuticals or for the lithium battery productions, where you need to have a lot of dry air in order to protect the quality of the batteries. But for turbines, it's this range of sizes. You normally will install one in the bottom of the tower to protect that entire. And depending on the design of the turbine, maybe you want to install a dehumidifier also up in the nacelle to protect some vital components. And some OEMs also want to put a dehumidifier into the hub. If you have a direct drive, for instance, you have the stator. And so that's extremely critical. And there could also be cases where you may want to, keep the inside of the blades dry as well, because there's a tendency of a lot of mold building up into the blades.
Gotcha. And so I assume most of this work is done in the factory, or are some companies retrofitting this? I'm sure if it's offshore, they're taking care of this before it ships out, right?
So that's a part of the integrated design. And so with the OEMs, of course, we need to understand how the cooling works and the other design specifications, because if they cool the entire nacelle and just pull in gazillions of cubic meters of air on an hourly basis, of course, our dehumidifier cannot, win over that system. So that's something we need to discuss. But then, it can also be retrofitted if we can fit it through the door, in through the tower. We are now doing some retrofits with various clients, and then basically we give them a manual to the service technicians, and then they can go out and do it themselves. It's not complicated.
So, Michael, where are you selling the system to now? Are you selling it directly to OEMs, or is it mostly to operators? And what parts of the world are you selling the system to?
So we're selling this system globally, and we work with most of the OEMs, and then we are now starting up, client relay, starting up business with some of the larger asset owners as well that also have their own service organizations. They are extremely keen on extending the lifetime of the turbines. Some even have a strategy that goes up to 40 or even 50 years lifetime on their turbines.
So my last question here for you, Michael, is that we have some folks who work in insurance, trying to just stay ahead and do their due diligence. So it sounds like this is another one of those pieces that is definitely something that's going to be on insurers' radar. Already is, obviously, but do you see this continuing to be more of of a requirement of something that's just like, look, this is going to make financial sense in the long run. Like when you talk about savings for coatings, and then obviously just hedging your bets in the future for not having some of these issues, like you said, taking a paint chip off while doing a repair. That's that little inroad for rust to just go crazy, right?
Yeah, I just have one good piece of advice to the insurance companies and also to the financiers and owners engineers, and that is put in a simple line into your requirements, a clause saying that relative humidity should never exceed 60% during transport, construction, and operations. Then let the owner or the OEM decide on how they want to solve this issue. Then you can sleep, well at night having this clause in.
That makes sense. Like you said, there could be different solutions for different people, but as long as that's there, then they can figure out how they want to take care of it. Exactly.
We see, if you have humidity above 60%, that's where you see mold start building up. You see corrosion. You will also see, the electrical failure starting at that point. And by just putting in, say, a speed limit of 60%, you should be okay.
Got it. That's good advice. Well, Michael, where can people follow up with you and with Cotes?
Yeah, you can check us out on our website, cotes.com, and there you can also find us on our link for our LinkedIn company page.
All right. So for everyone listening, we will link in the description below, no matter where you're listening or watching, so you can follow up with Michael Holm and learn more about Cotes. Michael, thank you so much for coming on the show with us and chatting.
Thank you. My pleasure.
All right, so moving on, we got one last topic here for today. We appreciate Michael's time. A great talk with him, really in depth about humidity, because it is a big deal. We're going to talk about GE and their lawsuit against Siemens Gamesa. So looks like a preliminary ruling, which Siemens Gamesa is going to appeal, that they've infringed one of these two patents held by GE here in the U.S., as far as zero voltage ride through. So the patent number here is, in case you want to go look it up, all you patent nerds, 7,629,705 is the patent number. Alan, you pull patents all the time to learn about other companies' technology, which is incredibly nerdy, but in character, on brand for you. Where do you fall on this patent lawsuit, and what's really at stake here for Siemens Gamesa?
Well, this is really fascinating because usually large companies are very careful about crossing patent territory, and they have typically a staff of corporate attorneys, one or two of which are patent experts who search the art. And if I'm Siemens Gamesa, anytime there's a Vestas or a GE or a Nordex or a Suzlon patent that's published, I'm going to read it and try to pass it along to the people in my engineering organization and say, hey, here's the latest and greatest from our competition, just so you know. And that has sort of two effects. One, it gives you the state of what the industry is and what your competitors are doing. But two, it tells you where you can't go. All right. So if you happen to be, secondarily developing a particular widget that, let's just say, GE has already patented, well, you're kind of stuck. So you have to either buy rights to the patent from GE or figure out another way to solve this problem. So getting into these patent disputes is really unusual between two large, smart corporations that have a lot of patent attorneys, and to let it, and secondarily, sort of let it to get to this level of now they're suing each other in a UK court, which gets to be expensive, and it's in the press, and everybody is unhappy, and you'd like to settle these things outside the courtroom, ideally. So there's something more to the story that I can't really put my fingers on yet. Is it a territorial thing in the UK because of the offshore wind development? Is GE trying to stake its territory and kind of shove Siemens out from even bidding for jobs, which could happen? I mean, you could get a settlement which would say, hey, Siemens Gamesa is infringed on a GE patent, therefore they are prohibited from selling a wind turbine in the United Kingdom for 5 years. That would really hurt Siemens. That would not be good. And like vice versa, right? If the roles reversed, GE would hate it too. So those are the kind of outcomes here, and you're really playing with fire, because once you bring in a judge in these patent disputes, you're never really sure where it's going to go. That's the trouble, is that you just don't. The outcome is one of 1,000 different ways it can go, and if it goes sideways on you, if you're GE and the judge says, "Hey, this is frivolous," and starts levying fines against you, that's not a good day either. So, Dan, do you see how why this would rarely get to this stage is because there's just so many barriers to stop this from happening. It's fascinating to see it get this far.
Yeah, so you're saying that internally, like in-house, their lawyers are probably going to check any new technologies they make to make sure they're compatible with existing patents. That seems like
Absolutely.
A sensible process. Yeah.
You have to. You have to, because the downside costs of that are so enormous. And attorneys are always, in my opinion, always the most cautious people on the planet, right? So you kind of get this downward direction of patents. So in an aircraft company, it tends to work like this. The patent attorney will see let's say I work for Boeing, and there's some Airbus patent. They'll distribute it around. They'll say, "Hey guys, this is what's going on. Make sure you don't screw up here and cost us a bunch of money because you're copying on an Airbus patent." Yeah, right. I mean, that's why you have those corporate patent attorney people on staff, is to avoid hundreds of millions or billion-dollar lawsuits. It can break your company, and if you do, in theory, steal intellectual property, you should pay a penalty for that. It is a piece of property. It's sort of a non-tangible piece of property, but it's a piece of property. It's a result of your hard-earned work and efforts, and that's why there's the patent law in the United States is part of the Constitution. So it is so embedded in a lot of different governments. It's taken very seriously. So once you get to this level, you're not playing anymore, right? This is big time stuff. With high-powered lawyers and a lot of researchers and supporting cast there, and you just don't want to be there. So, do you think this is going to go on much longer? Do you think after this first judgment, because doesn't it sound like Gamesa or Siemens Gamesa is going to appeal, like bring it to the next level? Yeah,
they are. They do intend to appeal, and of course, so there were two patents. The one I listed off, number 7629705, that one was not infringed. The judge determined the one that was infringed was their low voltage ride-through technology, not the zero ride-through. So the low voltage patent 6921985, that one is the one that they said they've infringed. If you're going to go pull patents. But yeah, it does. I don't know what the damages would be. Like, obviously that they haven't gotten to that stage of the lawsuit yet. But you're right. I mean, I'm sure they're nervous about what's at stake here. And I don't know how this technology works. So it's not like I know, hey, they're going to have to dig up this and replace that, or swap out these kind of. I'm not sure how that works, but yeah, there's going to be some significant damage, I guess, if this ruling sticks. So we'll have to see how it plays out. So that's going to do it for this week's Uptime podcast. Thanks again to our guest, Michael Holm from Cotes. Again, check out the show notes or description where you can learn more about him and their company. Be sure to subscribe to Uptime Tech News, which you'll find in the show notes or description of this podcast. And subscribe to Rosemary Barnes, who couldn't make it today, but she will be back next week. And you'll find her awesome YouTube channel in the show notes as well. Thanks again for listening. Be sure to subscribe to our show on iTunes, Spotify, Stitcher, YouTube, wherever you listen, and we'll see you here next week on the Uptime Wind Energy podcast. Operating a profitable wind farm is all about mitigating costs, minimizing risks, and being efficient with maintenance, repairs, and upgrades. It's incredibly expensive to send a team of rope access technicians up tower to make even simple repairs. We also know how costly lightning damage can be, requiring inspection, repairs, and downtime for even minor lightning strikes. Maximize the time efficiency of your techs and prevent future lightning damage by installing our Strike Tape LPS upgrade the next time your crews are going up on ropes. Learn more in today's show notes or visit us on the web at weatherguardwind.com.